Hello everyone, it's Arjun from Attacks. I hope you're staying well and safe out there. We got a lot to deliver on for our clients as well as producing new quality content. Once again, we are still working on producing a good demo video for our coronavirus initiative, in which we provide free of charge anonymization services for companies that want to exchange COVID-19 data in a way that protects people's individual privacy. Our company mainly exists for social good. We protect the human right to privacy and expand access to AI data innovation for all companies. Once again, please email me at arjun.banerjee@pridetex.com or just message me on LinkedIn if you're interested in collaborating with us. In other news, while our data anonymization platform is now available for beta testing on AWS Cloud, we're also planning to migrate it to our own site. We're looking for beta testers like you that can play around with our software on AWS. So if you're interested in helping us grow as a startup and contributing to our work, please reach out to me. So with a lot going on, I did not have enough time to cover the relationship between differential privacy and data protection laws such as HIPAA, GDPR, etc. Instead, I will talk about a similar topic with privacy by design. Today, we will briefly go over privacy by design and analyze how differential privacy satisfies its principles. We will also go over how our improvements to differential privacy better suit such principles. Privacy by design is a framework that was developed by Dr. Anne Cavoukian, the former Information and Privacy Commissioner of Ontario. It is a checklist to make sure that any company effectively integrates consumer privacy protection as a core feature of their data product. Now, applying classical differential privacy would satisfy only most principles of privacy by design. Unfortunately, it would not satisfy the first principle because it limits the insights and usability of the data product. As I mentioned previously, classical differential privacy transforms data into statistics for analysis, and just analyzing on statistics itself instead of raw individual data would limit insights or functionality with your company's data. This is why it is used only for certain applications in large companies and not all applications. However, it satisfies the second principle. Customers will still trust in your company and your brand for using a strong measure of privacy. It shows that you respect your customers first before growing your business. It also satisfies the third point. Differential privacy has been steeped in academia and thus has a lot of background in its study and use cases. Customers can be able to see how much their privacy will be protected with the measure epsilon. We can break it down for you in a way that you can tell your customers. It does not satisfy the fourth point because there is always this big trade-off between usability and analysis performance of the data versus individual privacy. This is related to the first point. At least you can still rely on the mathematical guarantees of classical differential privacy to satisfy the fifth point. Such guarantees protect the individuals at any stage of the anonymized data's lifecycle. Regarding the sixth point, the framework has only been created to protect privacy, and its methods can automatically transform or modify acquired data to protect individual privacy. Finally, with the seventh point, differential privacy is always applied before any dataset or information is disclosed to another party to protect the privacy of customers. Remember, there is always a privacy parameter epsilon that transforms the data into an anonymized format. This is a preventative, not remedial method. While classical differential privacy does not fit the privacy by design framework, we at Attacks improved upon classical differential privacy to satisfy all principles to the maximum possible extent, especially in terms of mitigating trade-offs with any functionality of data. Regarding the first point, our algorithm centers around retaining the same insights on the original data as the anonymized data with differential privacy, as discussed in our previous videos. It is a data-to-data transformation that shows individual data as opposed to classical differential privacy's data to statistics transformation that cannot do so. Thus, we would be able to enable full utility and insights of the data, satisfying privacy embedded into design. Regarding the fourth point, the anonymized data our algorithm produces is accurately representative of the original data. Unlike classical differential privacy, it is structurally the same as the original data so that data scientists can retain the same insights as the original data with the anonymized data. Furthermore, it optimizes for the maximum accuracy that can be retained while still preserving individual privacy over the dataset. Thus, we believe that our algorithm is positive sum in terms of privacy and data value. Thus, we can finally show that Private differential privacy satisfies privacy by design. That wraps up our presentation. Hope you learned a thing or two about privacy by design and differential privacy. Once again, I'd like to refer you to some links. The first link explains privacy by design really well if you're not too familiar with the framework. The second link goes somewhat in depth into the technicals of differential privacy. Maybe you can actually learn more by matching up some technical specs with privacy by design principles. In our next vlog, I hope that I can finally get into discussing the relationship between differential privacy and data protection laws such as GDPR, CCPA, HIPAA, etc. Thanks for listening. Hope for exciting things to come very soon, and stay in tune to hear more about our coronavirus initiative with the demo video. Stay safe out there.